Hello everyone. Today I'm going to talk about Project Pytheas, which was developed for Acme Robotics as a part of final project for the core software development for robotics. Before going further, let me give you my introduction. I am Yash Shah, a current graduate student at University of Maryland majoring in robotics. I have completed my bachelor's degree in electrical engineering and my experience includes working on face detection algorithms, planning modules for mobile robots, and also working on some machine learning algorithms. So coming back to the project, I have implemented a robotic software for Acme Robotics, which is a simulated robotic system capable of autonomously navigating and mapping in unknown environment. This project was developed on TurtleBot platform and along with that it uses ROS and its various packages. The system developed here has the following features. First of all, it can navigate unknown environments using Walker algorithm and along with it, it avoids obstacles. It can map the environment and save the map in the file. It can take the pictures whenever the user wants. It can stop or resume the motion of the robot as per the user commands. Also, it can change the linear speed of the robot and the threshold distance to detect the obstacles for the robot. The motivation to work on this project was mainly due to the number of applications that it covers. There can be a lot of instances where the surveillance is required but the humans cannot go in that area. That is where this type of robots give a helping hand. So the main applications of this software is where if we want to navigate certain unknown environments like offices or factories or even as a aid rescue efforts during the natural disasters. Also, we can do remote surveillance using this software. So generally speaking, this robot aims to make mapping jobs easier and for all sorts of applications by removing the manual nature of the current process. Here's the UML diagram for this project. Uh, Here we have a detect object class which detects if there is an obstacle in the front of the robot or not. Here's a cam class which gets the live feed of camera from the TurtleBot and displays it in a window, and also it can take the picture based on the user command and store it in a file. Here's a control motion class that basically decides whether to move forward, to rotate on its plates, uh, 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 and here's a TurtleBot class which based on the control motion commands drives the robot. Here's the activity diagram for the project. Uh, when we start the module, it starts the laser scan and uh, it processes the map and uh, and stores the map in the file. If there is an obstacle, it will rotate on its plate till the obstacle is removed and then move forward. If not, it will start moving forward. So after that, if there are any services called, it will work on that service. For example, if the user wants to change the speed, it will change the TurtleBot speed. If the user wants to change the distance threshold, or if the user wants to save the image, or if on the start or stop the motion of the robot, and then when the user presses the exit command, the software exists. Now I'll show you the live demo of how the project works. Now for the demo, first I'll have to clone my repository. So I have created a Catkin workspace in my home directory. I'll go to the source directory here and clone my repository. The cloning is done. Now I'll have to build the project. So for that I'll have to go to my workspace and then catkin underscore make. It will take some time to build. Yeah, so our project is finally built. Now before we run the demo, I'll have to source my setup.bash file. for the demo, I have created a launch file. So I'll use ROS launch. It will open Gazebo. Also, it will open a window that will show the live feed of the camera from TurtleBot, which is over here on the left upper side. We see that the robot has already started moving uh, based on the Walker algorithm. Now we'll open RViz to start the G mapping. I have opened another window, so I'll have to source my setup.bash and then ROS launch, name of my repo, launch file. We see that it has already started making the map. It will take 4 to 5 minutes to make the whole map for the project environment. So to save the map, first we'll have to go to the results folder, which I have already done here, and then type this command. The map has been saved. To see the map, we can type EOG, name of the map. Here is the map of the robot. Now we will see the services which I have incorporated in my project. The first service is to take an image. So I have started one more window, and then I'll have to source my setup.bash file. Now I'll call the service that will take the image. And I'll set the flag as true so that it takes the image. We got the response which is true, so our service has been successfully called. Now to see the image, we can go to the .ros folder. Here we can see that our image is saved here. Now we have one more service, that is to change the speed of the robot. That is change speed service. And we can set it to 1.0. Now to visualize that, I'll have to open the map. We can see that the speed of the robot has been increased to 1. Before it was 0.25 meter per second. Now there is another service to increase or decrease the threshold for the obstacle detection. I'll set it to 2. So now we'll be able to see that the robot turns quite at a more distance as compared to before. We have one more service, that is to start and stop the motion. If I set it true, it will stop the execution of the velocity of the robot, and if I type it false, it will start the robot again. Now coming back to the presentation, The future work for the robot would be the change in how to implement the how the robot navigates autonomously. Here, for this project, I'm using Walker algorithm, but I have faced a lot of issues in creating map based on Walker algorithm. So, if I'll have to come up with another algorithm that navigates autonomously and creates a good map. Another future work would be implementation of 3D mapping, and also after the map is constructed, the use of path planning algorithms to navigate in the region. Um, Thank you. That's all from my. If you have any questions, you can email me at ysshah